All right, so in this video, we're going to look at how to take a polynomial. All right, so there's 1, 2, 3 terms in the numerator and divide that by a monomial. All right, so please take notice. The main issue here is we're dividing by a monomial. We're just dividing by one thing down there, not two things. All right. What we're going to kind of leverage is it's like the distributive property. So you remember if I had 2x multiplied by 6x plus 2, I could take this one thing and multiply it by each individual things. It would become 2x multiplied by 6x plus 2x multiplied by 2. Well, it's going to be the same idea here, except with division. So I've got all of this divided by 8x cubed. What I'm going to do is, it's called splitting the numerator. And so what I do is I take each term individually, so 8x to the 8th, and I divide it by 8x to the 3rd. I take 18x to the 4th, and I divide that by 8x to the 3rd. And the same for that last one. Notice here it was subtraction, so I put the subtraction symbol there. And then all we do is we're going to end up simplifying each of these fractions individually. All right. So the why, I guess you're able to do something like this, give it a think, but it has to do with the fact that it's the rules that we use for adding and subtracting fractions. All right. So we're able to split a numerator into several terms, but we are not allowed, all right, maybe when we're not virtual or something, you can ask this question, but we're not allowed to split up a denominator like this. All right. It's only for taking several terms of a numerator and writing them individually. All right. Then you just simplify each of these by themselves. So 8 divided by 8, that completely simplifies. It goes down to 1. Then you've got 8x is up top, 3 down below. So you subtract those exponents, and you're just left with an x to the 5th power. I guess there's a 1 here, but you don't have to put it. And then minus 18 over 8. You can divide those both by 2. So that's going to give you a 9 and a 4. And then you're top heavy on this one. So 3 of these are going to cancel with 3 of those, leaving you 1x up in the top. All right, and then my third term, all right, 4 over 8, that's the same as 1/2. All right, so it'll be 1/2. And then, yeah, on your x parts, 3 here and 3 there, they completely cancel out. So it's just 1/2. That's what you would be left with. All right, that's all we can do with this one. We simplified each individual fraction by itself. Yeah, that's our answer. All right, this next one. So I've got all of this polynomial divided by this 9x squared. So again, I'm just going to take each individual term and divide it by the 9x squared. That's splitting up my numerator. So 6x to the 5th divided by 9x squared plus 9x squared divided by 9x squared, and the 12 as well, divided by 9x squared. Okay. And then we'll simplify each of these individually. All right, so for this one, 6 over 9, that's going to simplify down to 2/3. If you divide top and bottom by 3, so it's going to give us 2/3. And then this is going to be x to the 3rd power. I could either write the x to the 3rd power up here in the numerator. This time I feel like I'm just going to write it off to the side. So 2/3 x to the 3rd. Now here, 9x squared over 9x squared, that completely cancels out. But whenever you're doing, terms like this, I'm adding this term. And it's important to not just cross it out and forget about it. This is a thing. It's part of our problem here. All right, we're adding one whole is what this is. All right, I know when you cancel stuff out, usually you just ignore it completely. But here, they don't just cancel, so to speak. They are a thing. So it's one whole for that piece. All right, plus, and then our 12 and 9, you can divide those by 3. So that's going to give me a 4 up top, 3 down below. And then my x squared, there's nothing to simplify it with. So that x squared is going to remain in the denominator, not up top, not off to the side. That's it right there. Okay. Yeah, so what I meant by, you can't just cancel it out. You have to actually put 1. A lot of times, if you have an expression, say like, all right, let's say I had 3 times 2x, and I had 4 times 2x. Well, in this case, because the 2x is connected to the rest of these pieces by multiplication, we can literally just cancel them out and forget about them and call the answer 3/4, because what's happening here is that it's 3 multiplied by 1. And multiplying by 1 doesn't change anything, so I can live without it. But adding 1, which is what I have here, adding 1 whole, like that's important. That's part of the problem. That's part of the solution that I need. Hopefully that makes a little sense. Anyway, if not, please write it down and ask me. All right, last one here. This one's just got 2 variables. So split up that numerator. All right, 14x to the third y. And pause the video. Make sure you can split up this numerator yourself if you want to. 7xy minus 7x over 7xy. So we're just learning the rules or the things that we are allowed to do with these monomial expressions. Give them a think. Hopefully you see the reason we're allowed to do certain things. That's what you should be reaching for here. All right, so we split it up, and then we'll simplify them individually. So 14 over 7, that's just going to be a 2. So I got a whole number 2, or 2 over 1 if you want to put it like that. 1x is going to cancel with one of those, and so I've got x squared also in the numerator. And then the y's, they completely cancel out, so I don't even have to write them. They're gone. So that first term just becomes 2x squared. All right, minus. Now this one's a little interesting. So the 7x cancels with the 7x, but what I'm left with is a 1 up top and a y down below. So I do need to write it like that. The y is in the denominator, so I'm going to write it as 1 over y. All right. And then for my last term here, 27 and 7 do not share any common factors, so I won't be able to simplify those. The x's cancel. The y cancels with one of those y's, so I still have y's up top. I got 4 y's up top. All right, that is it for this one. All right, that is dividing by a monomial. All right, very different than dividing by a binomial, which we'll look at some other time.